Look at complex conjugation. So here I have x is equal to 3 plus root 2, and here x star is equal to 3 minus root 2. Now you may recognise that these are the same apart from we've got a plus root 2 here and a minus root 2 here. And these are what is known as conjugate pairs. So we're just going to have a look at what happens when we add and multiply a pair of conjugate pairs. So notice here that we have a surd here, root 2. So let's do this first one. So we have 3 plus root 2 plus 3 minus root 2. Hopefully we notice here that the plus 2 and the minus 2 cancel out, leaving with 3 plus 3, which is 6. So we got rid of the surd there. So then let's have a look at what happens when we multiply a conjugate pair together. So we'll have 3 plus root 2, 3 minus root 2. And you may already recognise this from GCSE. So 3 times 3 is 9. Then we're going to have minus 3 root 2 plus 3 root 2. And then the plus minus root 2 will become minus 2. So when we do that, you can see here we have a minus 3 root 2 and a plus root 2. They're going to cancel out. And then the 9 minus 2 is going to give us 7. If a conjugate pair like that, if when we add it, multiply it and get rid of surd, can it get rid of the imaginary part of our number? Let's see. So let's do first of all z plus z star and see what we get. So we end up with 3 plus 2i plus 3 minus 2i. We can see there the plus 2i and the minus 2i cancel out, giving us 3 plus 3, which is 6. So it does. That gets rid of our imaginary part. Then let's try multiplying it. So then we'll have 3 plus 2i, 3 minus 2i. 3 times by 3 is 9. Then we'll end up with minus 6i plus 6i. And then we'll end up with minus 2i squared. So I squared is just negative 1. So that would be negative 2 times by negative 1, which would actually just give us positive 2. So we'll have 9 here. The 6i's are going to cancel out the negative 6i plus the 6i, and then we'll have a plus 2 there, because we said that that minus 2i squared would just become a 2. It's minus 2 times by minus 1. So that's going to give us an answer of 7. So as you can see here, we've replaced the root 2 with a 2i for these two examples here. So we can see when we multiply or add a conjugate pair together, it removes surd here and it removes the imaginary parts here. And it gives us a way to realise something. So before we would be rationalising something, rationalising a denominator, here we might want to realise a denominator and get rid of that imaginary part. Here we've established that z and z star are complex conjugate pairs. Complex because they have a real and imaginary part, and then conjugate pair because we have that plus bi and that take away bi. Let's now have a look at a question which involves the complex conjugate pairs. So it says, given that z is equal to x plus iy, where x and y are both real numbers, find the value of x and y such that 3 minus I multiplied by z star plus 2iz is equal to 9 take away r. So here we have, we've just defined z star as our complex conjugate pair, because if z is x plus iy, the complex conjugate pair will be x minus iy. And then all I've done for my first step is I've just substituted those in. So 3 minus I, and then z star, x minus iy, put that there. And then we have our plus 2i multiplied by our z, which is x plus iy, and that is equal to 9 take away I. So let's now expand that out. So 3 multiplied by x will be 3x. 3 multiplied by minus iy will be minus 3iy. Then minus I times by x will be minus ix. And then minus I multiplied by minus iy will be plus I squared y. Then we have our plus 2i multiplied by x, that will be 2ix. And then 2i multiplied by iy will be 2i squared y. And that will be equal to 9 minus I. So now let's just evaluate those I squareds. So I squared, we should recall that that is just -1. If I is the square root of -1, square it, we get -1. So here, this I squared will become a -1, so that will just become minus y. So if you rewrite that out, that will be 3x minus 3iy minus ix minus y. And then if we look at this bit here, so the plus 2ix will be the same. And then we have 2i squared y. So I squared, we said, is -1. So times that by the 2, that'll be -2. So it'll be -2y is equal to 9, take away I. So what I'm going to do now is I'm going to gather up the real and imaginary parts. The real parts will add to 9, or the imaginary parts will add to -1 or -I. So this 3x is real. Then we have that minus y, and then we have the minus 2y. So that's real, and that's real. And then for the imaginary part, we have minus 3iy. We can put the I at the end, can't we? So if we put the I on the outside, so we'll have minus 3y, then we'll have a minus x, so we've done that minus 3, the minus x, and then the plus 2xi, and that will be equal to 9 minus I. So I've gathered my i's together, and I've gathered everything without an I together. So let's just clean that up. So that'll be 3x minus 3y plus minus 3y plus an x plus an xi is equal to 9 take away I. So all the real parts I know will add to 9. So I know now that 3x take away 3y is 9, because that's the real part. And I know the imaginary part, minus 3 plus x will be equal to minus 1. We could put the i's there, but it's the same thing as minus 1i. So we've now got two equations that we can solve. So what I might do here is, if I just make that 3y plus x is -1, I've got a negative 3y here, I've got a negative 3y here, so I'm just going to rearrange one of those and substitute it into the other one. So what I might do is I might just take away that x, so I might make that minus 3y is minus 1 minus x, and I'm going to substitute that into here. So that would be 3x, and then that would be minus 3y, so that would be minus 1 minus x is equal to 9. That then will then become 3x take away x is 2x, and then add the 1 is 10. So I therefore get x is 10, so 2x is 10, so therefore x is 5. And then let's substitute x as 5 into one of them. So let's just do it for this one. So let's do 3 lots of 5 minus 3y is equal to 9. This is 15. So if we do 15 take away 9, that would be 6 is equal to 3y. So therefore 2 is equal to y. Z is going to be 5 plus, they put iy, but I'm going to put 2i. So that is my solution. So next question, it wants us to write this fraction here, so 5 plus 4i over 2 minus 3i in the form a plus bi. So that means we need to get rid of the denominator so we can think about realising the denominator. So to do that, if we remember, we can multiply complex conjugate pairs together, and that will get rid of the imaginary part. So the complex conjugate pair of 2 take away 3i will be 2 plus 3i. To make sure the fraction remains equivalent, we have to multiply the top bit by 2 plus 3i as well. So let's now expand that out. So 5 times 2 is 10. 5 times by 3i is 15i. 4i times by 2 will be 8i. And then 4i multiplied by 3i will give us 12i squared on the top. And then on the bottom, we will get, hopefully, the imaginary part should go away. We'll get 2 times 2, which is 4. We will get a plus 6i. We will get a take away 6i. And we will get a minus 9i squared. So let's now evaluate that, clean that up, and deal with these I squared. So remember, I squared is just negative 1. So let's think about that 12i squared. So that would be 12 multiplied by negative 1, because I squared is negative 1. So that's just negative 12. And then this minus 9i squared is minus 9 multiplied by minus 1, giving us positive 9. We have a 10 take away 12, so that will be minus 2. And then a 15i plus an 8i, that will be 23i. And then on the bottom, we have the plus 6i and the minus 6i, which will cancel out. And then we have the 4 and the 9, that will make 13. So now I just need to put it in the form a plus bi, so let's just separate the real parts and the imaginary parts out, so they're not under one fraction. So that will be minus 2 over 13 plus 23 over 13i. I've written that in the form a plus bi. Given that z1 is equal to 3 plus 2i and z2 is 12 take away 5i over z1, find z2 in the form a plus bi, where a and b are real. So let's just write this out to replace z1 with our 3 plus 2i. So z2 is equal to 12 take away 5i over 3 plus 2i. So we need it in the form a plus bi. So let's realise our denominator by multiplying by the complex conjugate pair of 3 plus 2i, which is 3 minus 2i. So let's expand all of that out. So we have 12 multiplied by 3, that will be 36. We have the 12 multiplied by minus 2i, which is minus 24i. Then we have minus 15i there. And then we'll have plus 10i squared on the top. And then on the bottom, we have 3 times 3, which is 9. We're hoping we get rid of the i's here. That will be minus 6i, 3 times minus 2i, and then we'll have plus 6i, 3 times by 2i, and then we'll end up with minus 4i squared. So 10i squared will be 10 times by negative 1, so that's negative 10. And we have minus 4i squared, so that's minus 4 times by minus 1, which will actually get us positive 4. So now let's write all that out and clean it up a little bit. So we have the 36 take away 10, that will be 26. And then minus 24i take away 15i, that will be minus 39i. And then on the bottom, we have a 9 plus a 4, which is 13. And then the 6i and the minus 6i will cancel out, so we end up with that. So then let's write that out as 26 over 13 minus 39i over 13. That will become 2 minus 3i. And we have written it in the form a plus bi, or ib,